P.7 Day 1, solving equations with fractions and solving equations with rational expressions. And there's the assignment there. Okay, so equations are different than expressions. So far we've been looking at rational expressions, or fractions, you just say basically, and thus far there hasn't been an equation in there. So the way that we simplify just expressions compared to the way we simplify once we have an equal sign in there is different. So you're going to have to make that transition in your mind to the fact that there's a different process that's about to occur. All right, the first thing you do in solving equations is you need to find the least common denominator. Just like when you're adding and subtracting things, that's helpful. So factors of 4, well, if you break apart 4 into 2 and 2, those are the 2 prime factors. Factors of 7, there really are no factors of 7, it's just 7 times 1, so just say 7. Factors of 14 are 2 and 7. Okay, how many unique types of factors do I have? Well, I have a 2, that's one type, and I have a 7, that's the other type. That's it, just 2s and 7s. Whoops. There we go. Okay, what's the most 2's that I have in any one denominator? I have 2 of them here and 1 of them here, so the most would be 2. What's the most 7's that I have? I have 1 here and 1 here, so just 1. So the least common denominator would be 2 2's, 2 times 2, and 1 7. 7. So 2 times 2 is 4, and 4 times 7 is 28. So then that's our kind of magic number, the least common denominator. Now before, we would take things and we would multiply on the top and the bottom of every fraction. This time that's different. We're using a different technique. And here it is. The number 28 is actually going to be multiplied onto each of my 3 terms. Here's the first term, multiplied by 28. Here's the second term, right here, multiplied by 28. And, notice here I have subtracting x plus 5. I'm going to change that to adding. And I'm going to distribute the negative through, so it's going to be negative x and negative 5. So my third term is actually negative x, you could say minus 5, or plus a negative 5. I'm going to say minus 5. And again, that last term will be multiplied by 28. Okay, so 28, 28, 28, 1 on each term. Not 1 on each side, 1 on each term. Okay, so what happens here? 4 divides into 28 7 times. I'm not canceling, I'm dividing here. 14 goes into 28 2 times. And 7 goes into 28 4 times. So I've simply divided in each case by the denominator into 28. The rest of this is just solving the equation. So now I'm going to distribute through, so 7x minus 21 and 10 and negative 4x minus 20. Okay, solving. I'm going to add 4x on both sides. I'm going to add 21 on both sides. So x equals 11, or excuse me, 1. And that's my final answer. You can see the hardest part is figuring out what the least common denominator is. After you do that, the process of algebra is pretty straightforward. Example 2. Again, we're just going to try to figure out what types of denominators I have. Now, this part here, I've got 6 over x plus 3. I'm going to change this, rather than subtracting this fraction, I'm going to call it adding, and then move that onto 5, so it becomes negative 5. Always a good idea to deal with those negatives first. I'm going to factor this into x plus 3 and x minus 2. Okay, what types of factors do I have? I have an x plus 3 type of factor and an x minus 2 type of factor. What's the maximum number of x plus 3's I would have in any one term? I have one here, and I have one here, so just one. What's the maximum number of x minus 2's that I would have in any one denominator? Well, I've got one there and one there, so just one. So I have one of these and one of these in my least common denominator. So my least common denominator is x plus 3 times x minus 2. Okay, so then I take this whole thing and I'm going to multiply that onto each one of these. I have 3 terms. 1, 2, 3. Multiply that on each one. So it can be kind of wide, this process of solving now. But here I go. I'm going to multiply onto the first term, which is that, and onto the second term, whoops, which is that, and then the third one, if I can get it on my page. Oh, I'm not doing so good. I'm running out of space. Oh, I think I can make it though. There we go. Okay. So now things will actually cancel. Unlike the dividing in the first example, these actually cancel, so they just drop off. So x plus 3 cancels at x plus 3, and you get 6 times x minus 2. X minus 2's cancel, which gives you negative 5 times x plus 3. Here, all the factors cancel. Whoops. X plus 3's and the x minus 2's, and you just get negative 20. And then just solve. So I have 6x minus 12, negative 5x minus 15, and so you get x equals 7. Now, with this example, we have to check our answer. Why do we have to check our answer here when we didn't have to on number 1? Well, the answer is that number 1 had all simple number values in the denominator. It had things like 14 and 4 and 7. Now, 14 and 4 and 7 are never going to change to be anything else. They're always going to be 14 and 4 and 7. However, here, our denominators have variables in there, which means that they can be different numbers at different times, depending on different situations. So, because that x can be anything, we want to make sure that it's not a 0. Remember that? How that fractions cannot exist if the bottom is a 0? So, what kind of value would not work here? Well, obviously negative 3, because negative 3 plus positive 3 would be 0. So we can't have an answer that's negative 3. The other answer that we can't have would be positive 2. So, is our answer okay? Is 7 okay? Yeah. It doesn't make the denominator 0. So when I say that I want you to check it, I just mean that I want you to go back up into the original, expressions like this and substitute in the 7 for the x. So here this would be 7 plus 3 are 10. That's okay. It's not a 0. This would be 7 minus 2, which is 5. That's okay. That's not a 0. And this one would turn out to be 50, which is not a 0. So as you can see, 7 substituting in makes the denominators that are not 0, and that's okay. Oops. So that means 7 is an okay answer. Or you could simply just say, hey, it's not negative 3 or positive 2, it's 7, so it's okay.